today we are going to make a homemade forge. Oh, we have been wanting to have this little toy on Manual of the World for a long time. When we went to test the strength of the pineapple skin, we needed a little ball of red-hot steel, and for that, we had to improvise a kind of barbecue forge there, using some bricks. And it was a lot of work to actually get the sphere to turn red and glow. The forge was throwing out a bunch of sparks. It kept falling apart. But we loved the experience, and we said, wow, we need to have a decent forge on Manual of the World. So today, we are going to make a basic little forge, a starter forge to begin messing around, because it is something we do not know much about. We did a lot of research and ended up finding a channel called Porca's Pregos y Parafusos, where the guy made a nice one using a can. So, let us take a look. We bought a drum here that is 37 centimeters in diameter, but I am not going to use its full height because it is too tall. I am going to use a jigsaw. People were discussing here whether it would be better to use an angle grinder or not. I think the jigsaw is a bit more precise in this case, but it makes an absurd amount of noise. And anyway, it still depends a bit on my hand here. I am unsure about wearing gloves, since this saw might catch them and pull my hand, so I need to be very careful. This here is going to be the lid, and this is the little forge. Now I need to get this ready to receive the cement. It is the most annoying part of the whole thing. The lid needs a kind of chimney, so I am going to make a hole here that is 5 centimeters in diameter. I will insert a polyvinyl chloride pipe coated in Vaseline to prevent cement from sticking, then remove it later. And now we need a steel structure inside. I am going to make a wire ring. It is hard to make it stay at the right height, about halfway up here. And I also need 2 handles. I have already cut a mix of J and T here, but it is also hard to make this thing stay in the right position so I can put the cement in. It does not look good, but I think it works. In the forge itself, the challenge is much tougher. Its hole, where the furnace will be the diameter of this polyvinyl chloride pipe, 20 centimeters. It is similar to what I did on the lid, but this will take more work. I will make a wooden table to support the pipe inside, with 3 wires underneath for the table's legs. And I need to put a little hot glue around it so the concrete does not get in here. There is a tricky detail, which is the oxygen supply. The forge needs an air intake. This intake has to be underneath it, so I will have to make a hole here in the polyvinyl chloride to fit this pipe, and this pipe has to come from outside the forge. Most people position this pipe facing forward, but we will place it tangentially on the side so it enters from there and does this. The entry position forms an internal spiral. I am making holes for this pipe, but since it does not go in straight, the hole needs to be oval, which makes it more complicated. The worst part is I learned the drum hole did not need to be as oval as the inner one, but that will not matter in the end. I just need to seal this well, so the cement does not leak. We also built a small steel reinforcement for the cement inside, using thick wire I welded. Making this was annoying, but I think it will prevent the cement from cracking. I forgot to put solid, greasy Vaseline on the polyvinyl chloride, so the cement will stick. The Vaseline creates a greasy barrier between the cement and the polyvinyl chloride. If we do not add weight, this polyvinyl chloride pipe will float. Now let us mix the cement, okay? This mix is in the following proportion: 1 part cement to 1 part soil to 2 parts coarse sand, and also 20 grams of sugar for every 1 liter of cement. First, I am going to mix it dry so the materials get well combined, and then we will add water little by little. Because the big mistake when making the mix is adding too much water, and then you have to keep adding more ingredients or everything, yikes. We could not find the hoe, so we are using a mattock, but now its handle is coming off too. And I found out we do not even have a mason's trowel here. You guys were sabotaging me. Man, I was struggling with this hoe here. Now it is easy. Easy is a strong word, right? Why did we not just rent a concrete mixer, right? We rent a concrete mixer to make ice cream, but when we actually need it for cement, we do not use it. Then we have to mix cement with a mattock, and we do not even have a hoe. Man, everything is upside down in this world. No, let us make the forge. That is fun. That is a cool activity. We will be melting cans, but no, let us just keep mixing cement without a hoe. When the hoe finally arrives, you realize your back does not have the muscles it should have. I asked the guys if they had a mason's shovel, and Lucas got me this, a Jeep shovel. Let us hope this mix is enough. Everything is going wrong here. The support in the back came loose. Look, the wires when We will have to lift it up, and the pipe came apart. We made a lot of mortar, but not enough for the lid, so we will continue tomorrow. Our concrete experience is not great, but I think it will turn out cool. "40 days curing this concrete. It is no joke. It should be ready. But some cement got inside the iron pipe. How nice. Why did we not put paper or masking tape inside? Now let us try to get this polyvinyl chloride pipe out of here. I do not want to set it on fire because otherwise it will burn the plastic and create terrible smoke. So my idea is to blow hot air in here. The polyvinyl chloride should soften, letting me remove it like soft plastic. At least that is the idea, right? It is taking too long, but we just have to persevere. Wow, it is not coming off easily, you know. It is way too flexible. It was a lot more work than I expected. The Crucible, which is the pot where we melt things inside. I am going to make it with the fire extinguisher. The goal is to see if there is any pressure. Here there is not. I am loosening the cap to get the powder out, which is even clumpier than expired powdered milk. And it actually looks like powdered milk after that. The idea is to cut it with the grinder and make some kind of flaps. Here it looks like a star, but that is pretty much it. This crucible is too small for the forge, but let us go. The idea is to hang it on 2 iron bars, then remove the crucible from inside. We need to create a kind of reverse pliers, which is a spring with 2 tips. It sounds kind of weird when I say it like that, but when it actually works, you will see. The crucible has 2 holes. I squeeze the spring so it grips the crucible from inside. It is pretty cool. Time for the moment of truth, adding charcoal. I am not going to light a very strong fire. I think the idea at first is to light a really weak fire, mainly to dry out the cement. It has been 40 days, but it is still damp. I am afraid that if this water evaporates suddenly, it will crack all the cement. So the idea is to let it evaporate slowly. And then, yes, we can actually melt something. Lighting is quick. I use a torch to start it, then the heat gun supplies oxygen. It ignites easily. Why do I not want it to get too hot? Because it is full of water in here. If the water evaporates too fast, the steam will expand, right? Water going from liquid to gas will expand a lot, and that bursts like a bomb inside the concrete. At the beginning of the forge, a lot of different kinds of smoke will come out of here because there are things heating up for the first time. Like a little piece of wood we put at the bottom. It is heating up inside. The water is flowing out here, and the thermal camera shows what looks like fire up there. But there is actually no fire. This is just water vapor. And the part that is really hot is the pipe coming out of the heat blower. It is about 170 degrees hotter than the steam from the forge itself. There was a weird puff in here. I hope nothing exploded. Oh, look, I could just put the aluminum in like this, right? Like just a small piece. Maybe it will melt at this temperature. It is going to burn the paint off the extinguisher and produce nasty, plastic-like smoke. Let us place it on top. No. Let us put the aluminum inside so it does not get too hot. See, here we have a little bit of, what do you call this again? It is not gravel, it is, I forgot the name of this, when you cut, and there are some aluminum shavings left over. Anyway, this is easy to melt. Let us throw it in there. That way, it also keeps the extinguisher's metal from getting too hot. Shavings, guys, shavings. This is better now, is it not? Oh, it burst even more, right? A piece even came off. Wow, a piece flew off. Let us open it to see what happened. This is what is making smoke at the end. Wow, the aluminum has already gone all the way down. It is melting. The aluminum melted, and it is glowing red there. I think there is a lot of dirt in it, so there's a lot of slag. But let us record from up here, because the forge, somehow, is already working. The star-shaped flap is blocking charcoal addition. I will try removing it. Let us turn off the fire here for a bit and bend it down. It is not the easiest operation to do with the thing hot. Let us carry this aluminum here. I think this air intake pipe is too long, it loses speed. The air inside. Let us cut it here. Oh man, it spat out a blade of fire here when I stopped, but let us go. One of the functions of this hole up here is so we can stir the liquid down there, the aluminum that is melting, and also add more aluminum. Look how cool. It is nice and warm. It is making some weird noises, though. I do not think this top cement is going to hold up until the end. A downside of this forge is that fire escapes through the gap between the lid and the forge. It was meant to come out the top, since the edge of the crucible was supposed to rest inside the forge. But that did not happen. The crucible goes all the way down, leaving no space for the fire. It comes out the side, likely causing the lid to blow off. We will fix it next time. Two things. Why do we have to put this heat blower down here? This is important. To feed the fire with oxygen, the more we blow, the more fire can catch at the same time. This really speeds up the chemical reaction of the burning charcoal and will make the temperature get very high. In the past, there was a bellows, which is kind of like an air pump for inflating mattresses that people use to squeeze to feed the fire. Another cool thing is to think about what temperature this is reaching. We melted aluminum because we know that is about the limit of this forge. Depending on the type of aluminum, the aluminum alloy, it will start to melt between 500 and something and 600 and something degrees. It is roughly in that 600-degree range, and the aluminum is not melting quickly, so it will not go much higher than that. But it is enough for us to have a lot of fun. Here we have a kind of weird mass. It looks like soil made of aluminum. We call this slag. Basically, it is going to be dirt that is in the middle. It could be a piece of cement that fell in there. It could be aluminum oxide. In other words, the aluminum that reacted with the air formed a kind of aluminum rust, and all of this floats on the liquid aluminum that is down there. Melting metal in the forge always produces slag, and it is a good idea for us to remove this dirt before pouring it somewhere, before making any part. I am not removing it since I did not prepare anything special. You would need a spoon to take it out, which Lucas just brought me. Let us do a quick fix here. I think the crucible's bottom is pierced and leaking. Oh no, really? Look at the slag. It is over. The crucible got pierced, and everything leaked out. Even if I lift the crucible, it still got pierced. Wow, it did. All the aluminum leaked. Look, here, give me a brick. Let us see if we can at least use this little bit here to make an ingot. Let us go. Ah, look, if it had not gotten pierced. But this probably went well over 600 degrees because it pierced the steel, right? The steel deteriorated at that temperature. I doubt it melted, but it likely softened while we worked on it and pierced the extinguisher. I suspected from the beginning that it was very thin, that its wall was really thin, and that it would not hold up. Let us wait for the aluminum to harden so we can remove the ingots and see the results. There will be a huge pile of slag in the forge. I was worried aluminum would enter the pipe and ruin the forge, but now it will not. See, it slides now. I think we should tip the forge over, just tip it onto the ground here very carefully, so the aluminum can flow down, because otherwise it is going to harden at the bottom. We will have an aluminum floor in the forge that cannot be removed. Wow, man. Oh my God. Look at this. How much aluminum we managed to melt, and there is still more left in there. Let us take out the little ingot we made in the brick. Wow. It even has the mark from the brick here. Look how nice that is. It was so hot that these holes in the ingot are actually vapor bubbles from some moisture that was in the brick. In the end, I think our forge did not work, but it did. We melted about 4 kilos of aluminum, of which about 700 grams were left in the crucible after it broke. I'm going to take a guess here. The main problem was that we used a very thin fire extinguisher, which got a hole at the bottom and made all the aluminum leak out. But that was not the only problem. The cement that was in the forge is kind of crumbly. We noticed that as soon as we took out the polyvinyl chloride, it came off really easily. It looked like, I do not know, a clump of dirt. You scrape it and it keeps breaking. Now, after scraping it a bit with the iron, it is falling apart. That means we can still use this forge a few more times. It can handle a few more tests, but this forge will not stay at Manual of the World forever. We will need to build another. Anyway, I really like this kind of experiment because we learn a lot. If we build another forge, we are going to do it in a very different way. And I think you guys also learn a bunch of things in this video. It would be really cool if you left in the comments what you want us to melt. Maybe the last time this forge will work. Deal.